Vielen Dank. Ich hoffe, dass meine Deutsch nicht so schwierig sind. Aber ich glaube, ich gebe meine Sprache auf Englisch, weil das einfacher für mich und auch für die englische Personen, die hier bei uns von heute. So, that's it. As I said, my name is Lance Haig. I'm the Regional Manager of Solutions Engineering here responsible for the Germany, Switzerland, and Austria. And I've been in Germany 5 years now, and I came without German, and so I think I'm doing okay. And you can find me on Al Haig on all platforms that count, really. So today's talk is Zero Trust. What does it mean, and what does it mean for me? And I wanted to ask a question of everybody here. Who can explain to me what does Zero Trust mean in the IT context? Anybody? No, you can't answer, Jörn. Good call, good call. That's a good question. You can actually get some swag from that one. That's a really good one. Can you just put your hand up, whoever said that? There we go. Okay, well, all right, you understand this as well. Anyway, so let's get into the talk. What is Zero Trust security? And it's actually a very new, for most people, topic. It's a buzzword at the moment. And to understand it, we probably have to go back to where we started this IT journey. And as you can see from me, I've been around a long time. So I've been through everything from mainframes to whatever else we can have, right? And what we started on, what we still have in many data centers, is these four walls that are housing your network, your trusted network, your environments, and they protect your secrets. They protect your. They've got physical access to the environments. The networks are trusted, and the apps and databases inside this don't have to worry. You don't have to provide security for these because they're internally in your network. You protect everything via firewalls or firewall rules or IP addresses. So these things, you know that IP address A needs to talk to IP address B, and it's always been like that because it's in the CMDB, and you can't change the CMDB every year because it's just too much hassle. So you kind of just reuse the same machines and IP addresses over and over again. And the key factor, or the key part of this, is to deny unauthorized traffic from outside your four walls, your secure zone, as it were. But there's a question. Is there already someone on your network that's listening? And we've seen this in a number of cases over the last while, where somebody's VPN connection to their systems has been compromised, and the bad actor walked in over the VPN, landed on the other side, and started using and playing around with the systems and getting more access than they needed. And this brings us onto the cloud options, or the cloud journey that everybody's on at the moment. Digitalization, I still can't say that word. Digitalization makes things very difficult and challenging. And I was sitting here in the room earlier when the CERN talk was on earlier. And their challenges are way beyond everybody else's, but they will have the same scenario that we have here, where we've had dedicated resources on-premise. Now we want to stretch our on-premise into the cloud or wherever. And so you set up a private cloud, whether it's traditional VM-based cloud or whether it's a more fluid OpenStack-like cloud or Kubernetes, whatever. And this change has caused a lot of pressure on application delivery. So the pressure on application delivery is, we need to get this application pushed now and into the cloud in 15 minutes because there's a bug and we need to fix it now because the prices are too high or too low or whatever in our website. And in the old way of doing things, you would wait 2-3 weeks for things to change and go through testing and stuff. And that just can't happen now in the private cloud. You need to be able to get these applications into the cloud as fast and as quick as possible. And the other challenge there is, I was speaking to someone earlier about their systems of record sitting on the data center. That is true. You want to keep that stuff that's really valuable to you in the data center because, one, regulatory reasons. If you're a bank, there are many, and I've heard a lot of discussions around the tables here today, where regulatory requirements are a need and people misinterpreting them or people applying them to the rule. And this requires you to have your data centers on premise. So we all know that, these environments are, the cloud environments are much more ephemeral. You can spin up 100 machines in 10 minutes, and then 15 minutes later you destroy them, and they never existed. So this, for me, is a very challenging scenario when you're trying to apply this old way of thinking of your four walls, your IP address communication between machines, this old firewall-driven kind of security. And so Zero Trust has certain types of access, and these ones we're going to elaborate on as we go along in this journey. The first one is machine authentication and authorization. You need to, when you're in your environments, your new environments, your cloud environments, you need to know which machine is talking to which machine, and is that machine actually a machine that you deployed? This is, for me, a very important factor, because you can utilize, because we all trust the greater cloud. We all trust, hey, these machines in my cloud are my machines. But dude, are they really there? Are they really yours? So the thought pattern that you should have is that they come with an identity. And this identity is something that you can utilize in your Zero Trust journey. Machine-to-machine access. You have multiple connectivities. As we saw in the previous slide, you've got your on-premise data center, public cloud, your on-premise private cloud, and you've got your off-premise public clouds. But you have to have a way that these machines talk to each other. Now, if you have your old four-wall scenario, these machines didn't really need any kind of encryption to talk to each other. They could literally just talk to each other because that was allowed, that was okay. We didn't have to figure it out. But once you start traversing your connection to the cloud via your local high-speed link, you still need to consider there's a bad actor on that line. And many years ago, there was accusations of a lot of people reading traffic that was going through a data center. And the best way to do this is to provide a way that machines are allowed in the same way that you would allow humans access to another machine. In other words, this machine has an identity, it can communicate with another machine. Then the third type is human-to-machine access. So how do you regulate which machine, or which user, or person, if they need to, should have access to a machine? Now, ideally in a cloud environment, you don't want that. You want people to never touch your machines in the cloud. It should be, if it doesn't work, destroy it and recreate it. Right? That's what you want ideally in a cloud, because then no human touches, there's no last-minute dev changes in prod on the code in the system, which I've lived through myself, so I have part of this gray hair on my side here is from that. And that's what you want to make sure. You want to allow people access only and when they need it. Again, identifying themselves. And the last part of this access is human authentication and authorization. We all know about it, IAM, two-factor authentication, just people proving who they are and where they are. But again, what we're talking about is identity-driven controls. So this, for me, is one of the base ground points that Zero Trust lives on. You stop thinking in your old IP-based communication. You stop thinking in your old firewall rules, because you can automatically set firewall rules. If you worked in the cloud now, and or if you're using, for example, Terraform, you can access it, control your firewalls with code as you deploy your environments, right? Whether it's Cisco, whoever, F5, doesn't matter. So for me, this is where you need to find out who is making this change and are they allowed to make that change. So the identity-driven controls are very, very important. So Zero Trust is trust nothing, but authenticate and authorize everything. Now, this doesn't mean that you don't trust the people who work for you. This doesn't mean you don't trust your clouds. You just verify, is that the person that they say they are? Have they done their jump through the hoops, turn 3 times around, and stick their finger in the wall socket before they've authenticated themselves to the machine? Whatever your company needs. So some people do some strange things about retina scans and things like that. So it depends what you want to do. But you need to make sure that you can really know who that person or who that machine is. So this applies to machines, but also to humans accessing the environment. So that is what is Zero Trust, and I can kind of encapsulate it in that I'll expand a bit more on the points, but I want you to just start bearing this thought in mind that you need to start removing the human out of your networks, removing that human, that unnecessary human account, that unnecessary machine account out of your environments, because then you bring your attack vector down to what is just needed in the environment. And I'll expand a bit as we go along on this. So applied Zero Trust is, how does one do Zero Trust? And applied Zero Trust has 3 pillars according to me. I kind of coined this phrase and I'm sticking with it. Sounds good. 3 is easy to count. The first one is the principle of least privilege. I think everybody here must have heard about this. It's actually very valid. Just give your machine or human just enough access to do the job they need to do. So role-based access control is very important. How do you make sure that they don't have access to an extra set of IP addresses or systems that they don't need to? You need to make sure that your controls, your delivery mechanisms, your CI/CD pipelines are just granting that enough database access or enough system access for them to do their job, right? That's the one pillar. Again, it's a common theme here. Never trust, always verify. Again, you need to make sure that you verify the ID, the identity of the system, instance, machine. I heard lambdas and functions as a service and things like that. Always identify. Make sure that you know where that system's coming from. In Kubernetes, you've got those systems account that you can say, right, I created this system account. I know it is for this machine or this application, so this system account can have access to this part of the secrets, and those secrets can then be utilized by the system. And the last, and probably the most important, in a Zero Trust philosophy and a Zero Trust mindset, assume you've been breached all the time. Never leave anything unprotected. It's fine, it's only going to be a week. In a week that's gone downloaded somewhere. Always encrypt traffic between environments. Always make sure that you are protecting your data at rest. Always make sure that you are building this into your applications. And we're talking to, from today's questions that I've seen, there's developers, operators here, management. This is a mindset for everybody. Think about it. When you're building your application, it's compromised already. How am I going to stop this from being compromised further? Just think with that mindset. It's a company change. It's a company change that you need to have. So when you put them together in a slide, and this is for me, when you get shared the slides, you can see what I've said in one slide. But the challenge here is that you need to have a whole company get behind the Zero Trust methodology. The company has to follow it. Your networking team, the people who are serving coffee in the coffee room, they need to be behind this as well, right? Because you need to make sure that everybody understands who is here. Because what you want to do is you want to make sure that when something goes wrong, and it will, people will gain access to your system, their surface, their time to do damage is its absolute minimum. Really, really minimum. 3 minutes, 5 minutes, whatever. That's the time that they can do damage. And you make it really, really hard for people because they have to recompromise machines to continue and get longer time. So there's multiple ways of solving this challenge, this idea. There's multiple facets where you're going to be doing your IAM kind of part of it, or just working with databases, or networking, or firewalling, or load balancers. There's a bunch of them. For me, I'm going to focus more on the just-in-time access. How we limit the amount of time a secret or an access is granted to a service or a person. So we all know the mantra, identity-driven controls. We need to make sure that our systems are all identity driven. So you know that when you assign your machine an identity in AWS, GCP, whatever, that identity is known, it's trusted because it comes from the deployment. You then grant with that identity your machine access to the environments that you want them to do. Just making sure I'm getting all my notes. Yep. And then the first part here is your machine authentication and authorization. So you utilize this identity, and you use this identity to grant your machine access to the secret store. So this machine then gets its access to the secret store, gets itself a secret that it needs to do whatever job it needs to do, and then uses that secret. And then during the lifetime of that machine, it refreshes its secret. However long you configure it, however long you want it to be, could be days, weeks, hours, minutes, it's up to you. And this communication with the machine and the secret store allows you to drop, as I said, that attack vector, so that if this machine is compromised, they have literally just 2 minutes before the next rotation cycle comes through, and the secrets get automatically updated, or the PKI key gets rotated, and then they lose access. So they have a very short time frame. The second one is machine-to-machine access. You want to encrypt the network. We spoke about this earlier. You want to make sure that it's also, when your network is encrypted between point A and point P, whether it's a Kubernetes cluster, an OpenShift cluster, and a VM, the three of them are talking to each other. If you want to make sure that you are communicating and securely with your environments, you want to make sure that that whole encryption, that whole communication circle is encrypted with TLS and has certificates that are auto-rotated regularly, automatically, without you having to do anything. So again, even if they have access to your one key that unlocks the traffic for a short while, it gets rotated and it's gone. So that kind of attack vector is really, really small. So we're thinking, you see the trend here, trying to keep things as short as possible. The last thing, human-to-machine access. Again, as I said before, we want to treat humans very similar in their identity and their access. They only need access as and when they need it. We're not talking about your front-end users. They've got their web interface that they're going to be doing to whatever they're going to do there. But people who have the core access to your system, you want to make sure that they only get the access they need, and also it is approved process. They are using identity, so you don't have to stipulate that they need to communicate with this IP address. It is an automatic rooted scenario that you will allow them to have access to the machine. And then obviously, human authentication and authorization. I think we've kind of got this down now. After a few years of having IAM around clouds and everything, we can now do this. But this forms a key part of allowing humans access to the system to enable them to do the job they need to do, because you want them to be successful and you want them to be having the ability to do their job. So I was going to show a demo, but then it broke last night. So I'm going to show you what my demo would have done in slide format, and I hope you bear with me on that one. So here we have an application, Go, Python, whatever. It needs to access that database because it's going to be presenting secrets or a website or whatever to your user base that is going to consume this service. We have at the bottom there a secret store. Some of you might recognize the logo. And so this application running on a pod, a VM, a container, you name it, doesn't matter. This application starts up, says, hey, Mr. Vault, I need a secret for the database. Vault checks, has the application got its correct ID? Has it got its, is it allowed to access the database or get a database credentials? It says yes. It goes off to the Vault goes off to the database, creates a username and password for this application. It then brings the password back up to the application, and as you can see there, it's a randomized username, randomized password. And that's for this specific container or application or pod. If you spin this pod up 6,000 times, 6,000 unique logins. So if one password gets compromised, you only have to drop one machine. The rest of the passwords are still safe. Your application can still function. So this is where the just-in-time access is very, very important, that you just give it what it needs. The application then says, okay, fine, now I've got my website, I'm up and running, I can connect to the database, I'm really happy. Here comes your user. they want to buy some great stuff from you, got some widgets that they've bought. They've bought 300. It's going to make you a lot of commission. So they put their credit card into the system. And yes, that's a false credit card. It's not a real one. And the application then does the same methodology. It goes and it says, hey, I want to, Mr. Vault, I want to encrypt this credit card or transform it. Either way, both work. And I want to make sure that I need to get this done. And Vault checks, can the application do encryption of credit cards? If it does, it'll then pass back an encrypted password. Now, if you look at the second low there, that looks like a credit card. It has the four sets of digits that one would need, or 5, I think it is, 5, 4. But it is encrypted and can be decrypted. So it just looks different. Vault handles that for you. Then, now that the application has this encrypted credit card, it wants to write it now into the database. The encrypted credit card, at least the application says to Envoy, hey, Envoy, I need to connect to database B1. And Envoy goes, okay, console, does the application have access to database B1 or is allowed to? Yes, it's allowed to. Let's get that communication going. So then the transaction goes through the Envoy proxies to the other side. And now we've got inside this communication a TLS tunnel with encrypted data in the tunnel. So you're basically double protecting yourself, as it were. Then it gets to the other side, and the console agent on the other side, console and Envoy talking together. Hey, does this database, or this application, does it really have access? Yes, it does. You're allowed to lie through the database. Okay, it then lets it through the door. And what happens then, this database, or this credit card number is written in this format into the database. So that doesn't mean that means that you don't have to change your database. You could still have the same schema. You could still have everything, but this just gets written in there, and it's secured. If someone grabs it, so what? Right? Not really a thing. But you can do this not only for credit cards, security numbers, patterns that you match. These are the things that you need to do. So you need to protect people's, all PII, addresses, names, email addresses, all that type of stuff. You want to encrypt it, and then keep the stuff that is not that secure outside of the encrypted path of the application. And then just to give yourself a little bit more of security on the back end, you want to use something where your files or the storage that your databases are stored on is encrypted as well. So using a protocol like KMIP and using a key that is rotated randomly on that as well. So if someone grabs your whole system off the network, they can't get to it unless they have the key that's sitting on the other side and protected from somewhere else. And now we get to our users. How do they get access? Do the same way. Log in, do their dance, and get access to Boundary. And then in their list in Boundary, they will have a list of applications they're allowed to communicate with. They click the button. This then goes across to Vault and does the same dance. Are they allowed access? Are they who they say they are? If they are, yes. In this case, Vault says, yeah, you're great. You can have all SSH, RDP, and a database connection if you need to, because you're this really super duper database admin, and grants you access not only to the instance that the environment is running on, but also the database itself. And this access is never, ever, the developer or the admin never sees the keys, never sees the username and password. It's blind. That's what you need. That's what you need to have. You need to have this with a password that is seen by someone is compromised immediately, even though it's someone that you trust. That password is compromised. You need to think always compromised, remember? And that's that. And I hope it was informative, and I'm open to questions if anybody has any.